Hi, in today's video, I'll be giving a short introduction on linear programming using Python. So let's start with what is linear programming. And we'll do a recap as we have already previously explained how does the simplex algorithm work in a previous video using Excel. So we want to focus on the Python code for this video instead. So let's recap. Linear programming is a process of optimizing the value. So you are finding the maximum of a minimum of a given linear function given a set of constraints. So just like the previous video in which we do a linear optimization manually and using Excel, we will take the same example so that you can see that the Python produces the same results as what we have already calculated. So first you need to do in Python is that you need to import the linear programming tool so that Python has the function to optimize linear equations. So we run this first. So this will import the linear programming tool, and our problem, being the same as last time, is to maximize z, which equals to 180x plus 200y, and the constraints are 5x plus 4y less than or equals to 80 and 10x plus 20y less than or equals to 200. Now, because Python linear programming function does not do maximization, we actually need to convert this to a minimization problem, and we can simply do so by taking the negative of the z. So essentially this maximize, we can convert it to a minimize negative z, which equals to minus 180x minus 200y, where the constraints must always be also, in this case, less than or equals to work with the linear programming function. And since in our case the constraints are really less than or equals to, we do not need to change anything. Our decision variables are allowed to be larger or equals to 0 and have to be in our case too. For Python, there are many methods to optimize, and we'll see how we can select simplex later on. And so the first step after we import and we understand the problem and write down what we need to do, we need to write our objective function coefficients into an array. So we label this objective, which equals to negative 180 minus 200. So you need to remember that you need to minimize it now. And so for the left hand side of the inequalities, which are all this side, we write the coefficients into an array as well. So it's 5, 4 and 10, 20, you can see. And for the right hand side of the coefficients, it's just 80, 200. So this is a very basic step on how to write your coefficients into an array. The next step is not so important if there are no boundary conditions. Like in our case, our x and y are just known to be larger or equals to 0. So basically they go from 0 to infinity, but the default for the linear programming function in Python is already 0 to infinity. So these boundary conditions are not useful for this problem, but it's good to take note so that you can use it in other future problems that you might encounter boundary conditions. Now with everything set, all we need to do is to run the optimization problem, and we shall just call this optimization. To run it, you just put lead programming bracket, so C is your objective function, A underscore UB is your left hand side of the inequalities, and for B underscore UB equals to your right hand side of the inequalities. The reason why they are using A, B and C are just because the way mathematicians have done it is through matrices, and capital A just represents a large matrix and B just represents the coefficient matrix, and C is just they will just want to call it to represent your objective function. Next, your bounds, you can just insert your boundaries, which is 0 to infinity for both variables. And like I said earlier, there are different methods in Python, and by default it is actually the interior point method. But because we have been using the simplex algorithm in previous videos, we will still select method equals to simplex for this current video. So when you run this, it will run finish, and that means that you need to type the optimization to get its output. And so when you output it out, there will be a few results being shown. So one thing to take note of first is whether the success here is true or false. If it's true, means the algorithm worked and it is able to work out a solution to the minimization or maximization problem. But it is possible to be false when the algorithm fails to work out a solution, in which case you have to use other methods. Like I said, there are different methods. You can read the syntax on Python website, or in the worst case scenario that there is no solution because your constraints are contradicting each other when you work it out. And so, but in our case now it's true, which of course coincides with the previous video using Excel that we have done. And so let's just interpret the results. We can see that in our case, the bottom row, which is the x dot colon array, this just is the variables that optimizes the linear function. And again, x equals to 13 1/3 and y is 3 1/3, which is again, like I said, similar to what we have already got. As for the function now, because it was a maximization problem and we have converted to negative to make it a minimization problem, it just means that the maximum z achievable value is just without the negative sign. So it's just 3067, which is the same as what we have already got last time. And you can see Python has already a built-in linear programming function to use the simplex algorithm, and all you need to do when you're doing a problem is to make sure that you are able to mathematically write out systematically what is the objective function and what are the constraints. So then you just need to plug in the function and all the results will be shown by Python. So yes, linear programming is a pretty simple tool to use in Python, and the hardest part will always to be constructing the problem into mathematical formulation. Thank you. That's all for this video. As I said, it is an easy introduction into linear programming for Python, and if you have liked it, please like, share and subscribe. You can comment on anything that you don't understand and we'll be able to answer. Thank you.